Hello. Well, in this last part number 3, for advanced CAM simulation, what we need to do is how to simulate using the equations from Excel. Well, this is step that comes from the part number 2. We have to go to stop, close, and on results we have to return to model, and then on layout, single view. Okay. On this part, we can create a new solution. So let's go to constraints, delete. Okay. And then let's go to slider follower, and then on driver we have to select function, and then in function we have to create or select this green arrow to go to function manager, and then table in AFU, new. I'm going to type 01_AD from advanced or ADV _CAM simulation. This is the first creation step, ID. Don't worry about the XY axis definition. It's just telling you that the X is the time and the Y it's placement. So let's go to XY definition. We start on time equals 0. The increment, as you can see on the equations previously defined, it's 5 or 0.5 times 360. Okay. So we can say equal 5 over 0.5 times 360. Okay. Number of points, since what we have here, okay, it's 360. Every 5 degrees. Okay. So we have to select a number of points that can be defined under this position. Now, very important, you can copy on this X increment the value from this T 0.0278, but the problem in this case is that in some cases there are some decimals that are lost into the equation, so much better to use the expression as we already did. The number of points is going to be 72. Key in from text editor. Okay, this is 5.5 times 760. Okay. Okay, then delete what you have there. Go to copy TS. Copy. Without the last cell, which is going to be 2 on 0, but this point it's equal to this first point. So we avoid to paste it because it's going to be a circular definition. Okay, select OK, and then just to confirm, you can check on this edit data all the values are here, and then it starts on 0.0 seconds. 0.0277 is the increment or delta t. Set OK, and then the equation is already selected. Select OK, and then OK. We need to create a new solution. New solution. Then this one is solution CO2. 2 seconds, 100 steps. Click on solve with OK, so it is selected. OK. And then animation. And you can see the motion. A very important part is, as I told you, let me hide solids. And once again, simulate the position here. Exactly this point, as the equations say, is following, you see, every point of the cam. It doesn't count for the mathematical simulation that this has some more points of contact. Okay. See. But for the mathematical analysis, it's okay. So that's why it's important also to learn how to simulate this cam using mathematical equations. Okay, so let's see. Play on graphing once again. New solid slide follower. Add one curve. Okay. Oh, let me see. Have to go to layout. Layout settings. Side by side. Once again, double click on follower and click on this part. Okay. Home, animation, play. Okay. Okay. Now you can see this is a simulation. Now, what's the reason that we have this displacement? The distance from here to here is 2. Okay. But now we have almost 5. But you can see here that the radius is 1.5. As you can see from this data, 1.5. Okay. And the distance from this point to this point is 2. Then why we have almost 5 here? Since we have to have 3.5. Okay, the reason is this one. Let me show you this. Show and hide. Hide. Okay. The center of the axis for the slider is this one. So this motion is counting how the center moves, or how this one moves from the center. So from here to here, since this one is 3.5 over 2, because this whole distance is 3.5, this is the one it counts from this motion, for this motion. Okay. So the distance is also 2 inches, but we have 3.5 and 6 here, because that's the center of the slider according to coordinate systems. Okay. Thank you very much. That's all for the last part of the simulation using mathematical equations.